Join us for a discussion with Snowflake's Xin Huang on real-time data integrations, including StreamNative support for Snowpipe streaming and Snowflake's open catalog with Iceberg Tables. Thanks for taking the time to sit down with us today. For our listeners, my name is Dustin Nest. I'm StreamNative's technical trainer. But Xin, could you please introduce yourself and your role at Snowflake?
Sure. Hi, I'm Zin. I'm a product manager at Snowflake, focusing on the data engineering space, specifically data ingestion, both batch and streaming ingestion. I've been with Snowflake for over 4 years now, and previously I was at Microsoft Azure Storage, where I focused on object storage.
Just to give our listeners an idea of where we're headed today, we're going to be focusing on pushing the boundaries of how we can easily move data into Snowflake. Obviously, that's an area you're an expert in. And we're going to kind of focus more on the streaming side instead of the batch ingestion side, since we are StreamNative here. With StreamNative as a leader in modern streaming cloud native architecture, our goal is to help our customers maximize the use of their data with ease, including making their streaming data in platforms such as Snowflake for further processing. And this could be to use things like Snowflake's latest streaming APIs for data ingestion, or writing data directly in Iceberg format for use in Snowflake. So those are actually two topics I want to focus on today. If we could get started first with the data ingestion side through streaming APIs, can you give us a brief summary of data ingestion at Snowflake? And let's include Snowpipe in that as well.
For sure. Yeah, I think data ingestion is a very great topic. It's the first thing that customers do when they're working on their data pipelines. You have to ingest your data, transform the data, and then send that data out to your end customers or dashboards. So with data ingestion, there's batch and streaming ingestion. If we start on the batch side, you already have your files. They've been created by some process and stored in object storage like S3 or Azure Blob Storage. And you control how frequently you want to bring that data in. So with Snowflake, there's two ways of doing batch ingestion. They're really the two flavors of the same coin. We start with copy into statements. You do a copy into table with pointing to your stage definition. So you say, I want to copy these files into this table, and how frequently you want to run that. And you control the warehouse size. With Snowpipe, you can think of it as automated serverless copy. You set up cloud notification events such that when files land into your object storage, a cloud notification gets sent to Snowpipe. Snowpipe picks up that notification and loads your file almost immediately. You can think of that as a medium latency of about 30 seconds to a minute. So very fast still, but more of a micro batch continuous processing of files that have already been batched. On the other hand, you have more near real-time use cases of streaming ingestion. This is data that's being continuously generated, and you want to bring that data in as quickly as possible to have low latency and have reporting done on it much sooner than batch ingestion. So this is data that's on the order of seconds to single-digit seconds. So that's where Snowpipe streaming really comes in, is we wanted to move away from the batch processing. Batch will still continue to exist. A lot of customers will still do a lot of backfills and large data processing and ingestion with batch. But for those use cases where customers want to bring in their streaming data from Kafka, from Pulsar, or from their apps and databases directly with much lower latency, Snowpipe streaming excels to bring data in on the order of seconds at much lower costs.
When did Snowpipe streaming really come about, and what is the current status of it then?
Yeah, so we started working on Snowpipe streaming over 2 years ago, and we went GA in Summit of 2023. So we were in public preview and private preview for a little bit in 2022 and 2023, with GA fully in Summit of 2023. But we really started it because it's just the natural evolution of data ingestion. You always start with files that were already pre-built and stored for a long time. And then as data teams and companies get more advanced in their data engineering skills, they want to reduce their latencies from one day to a few hours to a few minutes to a few seconds. So it's that continuous improvement of ingestion latencies and processes of making that really robust data pipeline. And our team, luckily, we have a lot of experts that have worked on streaming processes in the past at their other companies or on their side projects, and we had a team of experts that we were able to understand the requirements from the customer. Customers have always said the existing streaming tools on the market are very complex. You have to have a PhD to almost tune all the knobs and understand, how do I get my best price performance ratio? How do I make sure my system doesn't fall over when there's peaks and valleys in throughput? So we wanted to really change that concept and make streaming as easy as possible to use, and really bring it fully into the Snowflake platform. Snowflake is known to having a really easy to use and customer friendly data analytics platform and data cloud. And streaming is the next frontier for us. So we built Snowpipe Streaming with the idea of making it super simple to use. You have a Java SDK that you can send your streaming data into. We'll take care of the batching, the optimizations, and loading it into a Snowflake table. And with the Java SDK, we were also able to build connectors on top of that. And that's just the first step. So over the last year, we've seen exponential growth in customers both adopting Snowpipe Streaming for existing use cases and adopting Snowpipe Streaming for net new use cases.
A couple things you said in there are things that I end up having to talk about a lot. It's the ability to scale, and then also scale resources up and down, and the cost with that. So are you able to scale the ingestion rate to extremely high levels and without basically any user intervention? And then what is the cost associated with that? Does it basically scale with throughput and not anything to do with having to over provision resources when you're expecting these peaks and valleys? How does that work on the Snowflake side?
Correct. It's really just a function of customers sending as much data as they have, and not having to worry too much about tuning the system. Snowpipe Streaming, like Snowpipe, is completely serverless on the Snowflake side. There's nothing that you have to control in terms of warehouse. You don't have to provision anything. It's pay as you go. So as much data as you're sending and how frequently you're sending is what you're charged. So if you're sending 1 kilobyte a second, we're charging you for the compute to process that. And you can scale from that to gigabytes per second. And Snowflake as a system will handle it. So all you have to do is worry about your throughput, your application, and sending your data as frequently as possible, and at your desired latency. So it's really how much data do you have and how fast do you want it to get to the Snowflake system, and that's something that the customer controls.
And for Snowpipe Streaming, then compared to Snowpipe, it does have the reduced complexity. Does that? But it's faster. So does that come with actually a cost reduction because of the reduced complexity, or how does that work between the two?
Yeah, for sure. It definitely comes with a reduced complexity and reduced cost for the streaming natives applications. So we've done a benchmarking, and I've done a 3-part blog series about best practices for data ingestion. Part 3 of that is focused just on Snowpipe Streaming and how, if you have a streaming application, comparing it with Snowpipe and Snowpipe Streaming can be 90% better in terms of latency, because the minimum latency is 1 second instead of 10 seconds or 30 seconds. And the cost is improved by up to 50%. So with streaming solutions, you have your streaming messaging platforms from Flink, Kinesis, Kafka, Pulsar. It makes sense to use Snowpipe Streaming just because of the reduced complexity, reduced latency, and reduced costs. It doesn't make sense to take your streaming data, batch it up, and then do data ingestion. It just makes sense to go from streaming to streaming directly into a table.
Well, the reduced cost will be a huge benefit. That's what our customers are talking about all the time, which is one of the huge benefits, again, of also using the Ursa engine. It reduces the complexity. We don't have bookkeeper. And then it reduces the storage costs because everything's directly in object store. So everyone loves to hear that, the reduced cost part of the story.
Yep, for sure.
Just to give our listeners an idea, StreamNative does already have a Snowpipe connector that's built into our cloud. You can deploy it in just a matter of seconds, just giving your endpoint at Snowflake and your credentials. I actually had worked on that YouTube video for that over a year ago. And then we don't currently have Snowpipe streaming, but it's coming very soon. It's something we're actively working on. So we have Snowpipe, but not Snowpipe streaming yet. So are you seeing that most net new applications, they use Snowpipe streaming instead of just Snowpipe because it has the reduced complexity?
It really depends on the use case. I would say there's still a lot of adoption of Snowpipe as well as Snowpipe streaming. I don't say Snowpipe streaming replaces Snowpipe. They're really complementary features. Snowpipe again is for continuous processing of files that already exist. You might have application or tool that you can't control the generation of the data directly. It's already coming to you from partners or from customers, and you already have files and you want to load it with Snowpipe in a continuous fashion. With Snowpipe streaming, you have control of your data generation. You have direct control to your applications, to your connectors, and they're able to talk to Snowflake directly with Snowpipe streaming. That's really the key use case. And we've seen both migrations from Snowpipe to Snowpipe streaming, as well as net new workloads on Snowpipe streaming. And the migrations were mostly because the customers had a native streaming service already, and just because they didn't have any other option, they were using Snowpipe. They were landing the files on S3 just for more durability and backups. But then they realized, hey, I don't need to do that. I can use Snowpipe streaming, do a migration to Snowpipe streaming, and have that reduce complexity, reduce costs, and reduce latency. So for those native streaming applications like Kafka, Flink, Pulsar, it really makes sense to use Snowpipe streaming. But if you have files already, it doesn't make sense for you to read the whole file and rewrite it through Snowpipe streaming. So they're two complementary use cases, and it really depends on what your needs are.
I would like to change direction a little bit into another way of getting data into Snowflake or storage within Snowflake. It kind of works both ways, and I want to get into both ideas. I want to move into open table formats and Snowflake's use of Iceberg. And then the term streaming augmented lakehouse has kind of come up around that as well. I know that when data is saved in Snowflake, one of the options is to expose it in Iceberg format. But it's also possible to write data into Iceberg tables. And then if they have a catalog, you would then be able to read that by Snowflake. Can you talk about both of those options? And maybe if you want to give a little bit of background about Snowflake's history with adopting Iceberg, things like that. So I'll leave it open to you to get started in this discussion.
Yeah, for sure. I think Iceberg is an amazing technology, and coming from the object storage space, I've really watched it grow over the past few years. And Snowflake has been really contributing to the Iceberg space in terms of supporting the open table formats, contributing back to open source, and now also supporting this streaming augmented lakehouse. So to step back a little bit, you hit it correctly on the head. There's a lot of existing use cases of Iceberg, but there's also a lot of net new use cases of Iceberg where customers are now just slowly learning about it and learning to adopt it to their data engineering pipelines. So for those larger customers who have existing Iceberg tables, they already have their Parquet files and Parquet Iceberg metadata written and managed by a catalog. What they can do with that is create a Iceberg table on the Snowflake side and then just point it to the catalog that they have, either a Iceberg REST, Open REST catalog, the Apache Polaris catalog, or AWS Glue catalog. And what we'll do is we'll use the serverless infrastructure that Snowpipe is built on to pull and refresh those tables. So you're keeping your Iceberg tables that were created outside of Snowflake up to date and queryable on Snowflake as a platform. So that's if you have an existing Iceberg data lake already. If you don't have an Iceberg data lake and you're just new to the journey to Iceberg, Snowflake has made it really simple to get your data into Iceberg compatible formats. We've made it such that copy, Snowpipe, Snowpipe streaming. These same three interfaces allow you to write to native Snowflake tables as well as Apache Iceberg tables. So you don't have to learn anything new. You can just plug and drop your table type onto the Snowflake side, and your existing data pipelines and data engineering processes will be able to write to Apache Iceberg Tables, and they'll be written to a catalog and queryable by other engines. So with Copy and Snowpipe, you might have files that are CSV JSON that are not Iceberg compatible. With Copy and Snowpipe, we can still take those CSV and JSON files and convert them automatically to Parquet files for you. So previously, people were doing this offline with Spark or custom tools, and that's additional complexity. With Snowflake, you're taking your file formats as you receive them from your customers or from your applications. They're continuously ingested and converted to Parquet and made available as a Iceberg table. With Snowpipe streaming, it's the same thing. Your applications were inserting your rows into the Snowpipe streaming SDK, and then going to a native Snowflake table. Now you just say, I wanted to go to a Iceberg table. That's just one configuration that you put in the SDK settings. And then the same insert rows API that you're sending your rows to will now send to an Iceberg table. We will write the Parquet files for you, write the Iceberg metadata, and then handle the table maintenance and compaction, because with streaming, there's going to be small writes, and we want to make sure that your data is optimized. So that's really the benefit of using Snowflake as your data platform for Iceberg. Is Snowflake takes care of all the table maintenance, all the compression, and all the security for you, versus building it on your own and then just federating that table to Snowflake. But we support both. It just depends on how sophisticated of a customer you are on Iceberg, where you are in your journey, and really we just want to make it simple and contribute back to the Iceberg community.
Are there any specific use cases or industries that have been adopting Iceberg more, or where has the adoption been strongest? What is it enabling customers to do?
I think it's really been strong all over in every industry. Historically, it was used by some of the largest customers. Netflix and Apple have been huge proponents of Iceberg and contributors to Iceberg in the past, but we've seen a lot of small and medium-sized businesses also now starting to look at Iceberg, just because of the open table format, allowing them to take advantage of cheap storage that has gone incredibly cheap over the last decade, but also being able to export that and share those tables with different teams securely, and they might be using different tools. So having Iceberg table that's an open table format, being accessible by multiple tools and different skill sets within the company is really the key benefit.
I think, and the key here is that Iceberg tables are stored in object storage, right? Which is where the cheapness comes from. And then you don't make multiple copies of it inside of different applications. Everyone can just access it. And then who
Correct.
can read and who can write depends on who owns the catalog and what permissions people have, I believe.
Correct. It's just one table. You don't have to make a different copy for different teams. They can all access the same Parquet files, and it just really depends on the metadata that they're accessing through the catalog. So someone might be accessing just part of a table. Someone might be accessing the whole table. So you can control that.
And then one reason I wanted to bring it up is the idea of streaming augmented lakehouse. To give you an idea of what we do at StreamNative as well, you may have heard this already, but we have two engines. We have our classic engine and we have our Ursa engine. The classic engine stores data in our typical manner in Bookkeeper, but we have the ability to then move that data over into object storage in open formats like Iceberg, like we've been talking about. So then once that data is in Iceberg, it should be accessible, which is something I'm actively working on, testing with our engineering teams, is moving that data over into Iceberg formats. We tend to do that in a fashion where it's kind of a two-step, because our Bookkeeper is known for having extremely low latency, whereas when you work in object storage, the latency is going to be slightly higher, which is not always okay for streaming applications. But our Ursa engine actually gets rid of Bookkeeper in some instances and allows all of the data backend for the entire platform to always be S3. or other platforms as well, object storage, but it would just be then directly in Iceberg Tables. There's still a slight latency in that case because we do a two-step, first to S3 and then into Iceberg, but that's more of a compaction process.
Yep.
Because Iceberg Tables do take some time for compaction. As you had mentioned as well, there's always a compaction process. But that would greatly reduce the cost because everything would be just going straight to Iceberg Tables. So in that case, our hope is that customers would basically be able to write directly everything into Iceberg Tables, and then Snowflake just can immediately see that data. There's no additional step of even having to transfer the data into Snowflake using Snowpipe streaming and then put it in Iceberg. We want to write directly to Iceberg, and then it's just another table that Snowflake sees and is able to read from. I believe in that case, it might be a read only because we're the ones primarily writing, and we don't want you to mess up our message ordering and all of that. We're going to own that table because that's our back end of our application. But I believe I've been playing around with Snowflake. I would think, and I'm actively testing this type of stuff, it would be cool if I could then create views of that data, which then would maybe have subsets of information in them or time frames, which you could then put additional restrictions on who can see it. So then maybe users inside Snowflake would be able to just see views of my Iceberg backend for StreamNative.
Yeah, for sure. And what you're talking about is what I was saying about the auto refreshing and the federation of the Iceberg table. So the Ursa engine is creating the Iceberg table. They created the Parquet files and the metadata, and you're the writer, you know how to manage it. Snowflake just wants to be the reader. So that's where the auto refresh capability for externally managed Iceberg tables comes in. Once you've created the Iceberg table, it's synced to Snowflake and it's immediately queryable. And we are working on capabilities of creating transformations on top of those externally managed Iceberg tables and views on top of that. Recently at Build, where we announced our support for unified ingestion to Snowflake native tables and Iceberg tables, we also had support for dynamic tables support for Iceberg. So dynamic tables is our also streaming transformation solution where you can define your base table, you can do joins, you can do window functions, any SQL transformations. And as the data comes in, we will only do the processing if there's net new data or on a defined target lag interval. So this is something that we will support for externally managed Iceberg tables in the future as well, where you have a table created by the Ursa engine and you want to only select certain columns or certain rows and send that to a different data team. That's where dynamic tables can help with that. You'll still have your base Iceberg table and dynamic tables for different teams and different processes. And it's all supported and backed by Iceberg on object storage.
I want to make a switch over to AI to make some final things about what people can do, or final comments about what people can do with their data. But any other comments you have about Snowpipe streaming or Iceberg?
Yeah, the only comment I would say for streaming to Iceberg and the concept of streaming augmented lakehouses, I think we're still very much in the early phases here. Iceberg has been seeing a lot of traction and growth, but streaming support for Iceberg is still very new and it's not supported widely yet. I think Snowflake has built Snowflake streaming support for Iceberg, and really we've made it super easy to get streaming data into Iceberg. But I know a lot of companies like StreamNative are also working on capabilities, and the space is going to continue to grow. And I'm really excited about that. So I think streaming is still net new technologies that a lot of customers have not yet adopted. Iceberg is being adopted. So I think over the next few years, we're going to see a lot of new innovations and a lot of adoption from the whole industry.
I do want to bring up a little bit about AI. I know you're not a product manager in that space, but one of the reasons people are very interested in getting their data into streaming augmented lakehouse might be able to do more real-time data engineering. I just want to bring up two things that I've been noticing a lot with Snowflake, and I'm starting to test out with this real-time data. The first is Snowflake Snowpark. I believe it's been around for at least a year, if not longer. It's not new, but just for our listeners, I believe that's all of the execution of Python runtime environments for ML applications, and that should be able to access basically all of your data that's inside of Snowflake. You want to make any comments on that? On Snowpark first?
Yeah, for sure. Yes, Snowpark is really amazing for data engineering. It's actually older than 1 year. I believe it's at least 2 to 3 years old now. We've announced it at Summit probably in 2021 or 2022. And it's a set of libraries and code execution environment that allows you to run Python, Scala, Java on top of your data within Snowflake. So you might be working with data frames, and Snowpark is the ability to transform that data in data frames before storing it into your tables again.
And then our goal on our side at StreamNative would be to allow you to get your streaming data either using Snowpipe streaming or an Iceberg table to get it into Snowflake as quickly as possible, so you can do your ML training on your models. In the case of Snowflake Snowpark, and then the other one I wanted to bring up was Snowflake Cortex AI. Which seems extremely exciting. I've played around with LLMs before and just using APIs. It sounds like you guys can fully host LLMs and expose those through APIs, which would make it super easy for anyone to be able to use those models with their Snowflake data. So if you want to make any comments on that.
Yeah, for sure. Cortex has been amazing at Snowflake. I'm not the expert on that, but it really depends on how much data you have on Snowflake and how fast you can get the data in. And data ingestion is the key to that. And I've really been happy with working with the Cortex team on making sure that both batch ingestion and streaming ingestion integrates with Cortex, such that you're able to derive value through LLMs on top of your data, and getting that data in a efficient and latency sensitive manner to your customers.
And it looks like you guys are adding new models, so you're adding state of the art. I saw on your homepage you're adding more support for Anthropic, so that's very exciting. Keep that up so people can. I guess the goal in that case, it's always great if you have one API like Cortex AI. You can switch between models, test out what you need, figure out what you need for production. So it can probably get you your time to value down.
Yep. Yeah. Snowflake is always working with our partners, and at Build we announced support for the latest Anthropic model, and we also support models from Llama and ChatGPT and others. So it's really have one platform. Your data is here, your AI models are here, and you're able to use your data and the models that fit your business use cases. So you know your latency, you know your business, and you know your data. And Snowflake is there to be that one data cloud to support all your data engineering and data processing needs.
Any final comments?
No, nothing. I don't have anything, but I'm really looking forward to StreamNative's support for Snowpipe streaming, and it's been a great collaboration. And I think we have a lot of joint customers that are looking forward to lower latency and lower costs with direct integration from StreamNative, getting their Pulsar data into Snowflake.
Yep, and I'm very excited about continuing to test Ursa Engine with Iceberg backend and getting that data into Snowflake as well. So I will be talking to you more and more probably as we continue down this very exciting journey of streaming augmented lakehouse as well.
Awesome.
All right.
Looking forward to it.
Thank you so much.
Thank you.
Yep.